Hi, my name is Kanika Klanis and you're watching the video Parks-Helveston 3-step test and Bielschowsky head tilt test. In this video, we will be discussing how to utilise these assessments to identify the affected muscle or the palsy muscle where you have a neurogenic palsy. Before we proceed, I would also like to note at this point, or you to be aware that the Bielschowsky head tilt test actually forms one of the steps that's part of the Parks-Helveston 3-step test. Okay, so why do we perform the Parks-Helveston 3-step test? Well, it assists us in isolating the vertical muscle palsy. So if on cover test you notice a vertical deviation and neurogenic palsy is suspected, then the Parks-Helveston 3-step test will assist us in identifying the muscle that is palsied. More specifically, it differentiates between a palsy of the oblique muscle or of the rectus muscle. And finally, most commonly, it's utilised to distinguish between a superior oblique palsy and a superior rectus palsy. Okay, in terms of the Parks 3 steps, it's actually a three-step process, or there are 3 steps to the assessment that will assist you to identify the palsied muscle. The first step is assessing the patient in primary position and taking a look at the vertical deviation in that position. Step 2 requires us to look at the vertical deviation in right gaze and left gaze, so dextroversion and lavoversion. And the third step includes the Bielschowsky head tilt test. As you'll see in my note on the right-hand side, you can perform the cover test and the prism cover test at each of these steps, so you can have a look and measure the vertical deviation in primary position, in right, left gaze, and on tilt. And it's important to note that in steps 2 and 3, what we're looking for is an increase in the vertical deviation from primary position. So in step 1, you identify the vertical deviation in primary. In step 2, you're looking at which horizontal position, right gaze or left gaze, is there an increase in the vertical deviation. And in the third step, you're tilting the patient right, tilting the patient left, and seeing in which of those 2 positions is there an increase in height. Okay, so the final 2 steps are comparing 2 positions and having a look where there is an increase in the vertical deviation. So what are we effectively doing as we proceed through the 3 steps? Well, we're identifying potential muscles that could be affected, and through proceeding through the 3 steps, we're narrowing the possibilities, and the third step will actually identify the single muscle or isolate the muscle that is affected. So in step 1, we'll see in a moment that of the 8 extraocular muscles that we have, we will identify 4 potentially affected muscles. The second step will narrow this down to 2, and the final step will identify the affected muscle. Okay, let's start off with the first step. So as I mentioned just a moment ago, in the first step, we are interested in the deviation in primary position. And what we can see here is that the patient has a right hyperdeviation. Now, if you go back to your notes or the video on deviations in incompetence strabismus, you'll note that in order for the eye to be hyperdeviating, that one of the 2 depressors must be the affected muscle. So we immediately have 2 potentially affected muscles, the right inferior rectus or the right superior oblique. If one of those muscles was palsied, it would cause a hyperdeviation of the right eye. However, we need to also consider the possibility that the affected eye is not the right eye, but is the left eye, and the patient is fixing with this eye. If indeed the left eye was the affected eye and is fixing, in order for us to observe a right hyperdeviation as we do here, it would mean that the left eye, when it wasn't fixing, was hypotropic. So imagine if you were fixing, or if this patient was fixing with the right eye would come down, as would the left eye, and we'd see a left hypo. So if the left eye is actually fixing, that left eye will come up to take up fixation, and we see the right hyper as we do here. So we need to consider that the left eye could be the affected eye even if it is the fixing eye. Okay, now in order for the left eye to be hypo, then it must be one of the two elevators that could be potentially affected. So in this instance, we need to consider that the left inferior oblique or the left superior rectus are potentially one of the muscles that are or is affected. So in conclusion, what you will have is, after step 1, you'll have two depressors of one eye that could potentially be the cause of the deviation, or the two elevators of the other eye that could potentially be the cause of the palsy or the vertical deviation in priming position. Okay, so step 1, we've immediately identified of the 8 extraocular muscles, we have now 4 that are potentially affected. And so we'll move now to the next step to isolate or narrow this further down to 2 muscles. Okay, how do we do this? Well, what we're interested in now is to move the patient into right gaze and into left gaze and look at the vertical deviation in either of those positions. Why are we interested in doing this? Well, when the patient looks over into right gaze, the vertical muscles that could potentially affect the vertical deviation in this position are only 4. So if we have a look over here to the right, if the patient looks over to the right, the 4 potentially affected muscles are the right superior rectus and right inferior rectus, and potentially the left inferior oblique and the left superior oblique. And this is because they work in this particular field of gaze. And when the patient moves over to the left, well, then we have the other set of 4 muscles that could potentially be affected. The right inferior oblique, right superior oblique, left superior rectus, left inferior rectus. And if we have a look again at the images above here, then just reiterating what I've just commented on, when we look over into right gaze, these are the 4 vertical muscles that could impact on the vertical deviation in this position. And when we look over to the left, these are the 4 muscles that could impact on the vertical deviation. Okay, so this is the principle by which we're going to utilize to now isolate or remove 2 of those 4 muscles that we thought could be affected, and to remain with 2 potentials. Okay, to work through this, let's go back to our original example of a patient with a right hyperdeviation. Now, we said if you've got a right hyperdeviation, potentially the 2 depressors of the right eye are the affected muscles, or the 2 elevators of the other eye are potentially the affected muscles. Now, the next step is to have a look at where is there an increase in the vertical deviation. So this is why measurement is important. So we'll measure the patient in primary position, the vertical deviation in primary position. We'll measure the deviation in right gaze, and we'll measure the deviation in left gaze. Now, upon observation, we can see here that the increase occurs in left gaze, not in right gaze. In right gaze, we don't see any hyperdeviation. Okay, why is this important? Let's have a look at the patient in right gaze. Of the 4 muscles we identified above, the 2 that could potentially impact on the vertical deviation in right gaze is the left inferior oblique and the right inferior rectus. Now, given that we've seen no increase in the vertical deviation, this is telling us that these muscles cannot be the affected muscle, because had they been the affected muscle, that results in an increase in the vertical deviation. So we can remove these 2 from being the potentially affected muscle or the affected muscle. So when we move over to left gaze, in this instance, we've got the other 2 potentials, the right superior oblique and the left superior rectus. And now we know that these are the 2 that we need to consider as being the affected muscles. So, step 3, we do the Bielschowsky head tilt test. If you go back to neuroophthalmology, you'll recall that the utricular reflex is stimulated by tilting the head. And what we see through this is a compensatory eye movement, whereby the eyes will excycloduct or encycloduct, depending on the head tilt that we have. So if we look at the image here to the right, we've got a patient tilting to the right, and what we see here is that their right eye will encycloduct, whilst their left eye will excycloduct when in this position. On the other hand, when we see the patient tilting to the left eye is encycloducting and the right eye is excycloducting. Okay, so the right eye will encycloduct when tilting to the right, but excycloduct when tilting to the left. And again, with the left eye, there is a reversal in this depending on the tilt. So we have excycloduction when we tilt to the right and encycloduction when we tilt to the left. Okay, this is the principle we're working with. How does this assist us in working out which of the two potentially affected muscles is indeed the affected muscle? In essence, what we'll see is an increase in the deviation when the patient tilts their head to the side where the affected muscle is required to encyclo or excycloduct the eye, depending on the action, obviously, of the extraocular muscle that's been palsied. Now, before I move on to showing you an example of how do we arrive to the affected muscle, we need to just cover a couple more points regarding the principles of the Bielschowsky head tilt test and what's occurring when we've actually tilted the head to the right and the left. Now, I've just mentioned that when we tilt, for instance, to the right, one eye will encycloduct, the other will excycloduct. Now, what we need to consider is which muscles or extraocular muscles, which vertical muscles are being recruited to encycloduct the eye or excycloduct the eye. If we have a look here, when the head is tilted to the right, we see that when we have an encycloducting eye, we will recruit the two superior muscles, the superior oblique and the superior rectus. And when the eye is encycloducting, the inferior muscles are recruited, the inferior rectus and the inferior oblique. And the same goes when we tilt, of course, to the left. When we're encycloducting the eye, or when the eye is encycloducting, the superior extraocular muscles are being recruited to perform that action, and when the eye is excycloducting, the inferior muscles are being recruited to perform that action. Okay, one other point. What you notice is that the two muscles that are being recruited in terms of creating encycloduction or excycloduction actually have opposing vertical actions. So if we take a look here at the right superior rectus, we see that the right superior rectus is an elevator, whilst the right superior oblique is a depressor. Okay, and for the excycloductors, the same. The inferior oblique is the elevator and the inferior rectus is the depressor. And this is important to note because, say for instance, you have a left inferior rectus palsy, when the patient has tilted to the right and the left eye is encycloducting, the left inferior oblique will be recruited, as will be the left inferior rectus, but the left inferior oblique will remain unopposed by the left inferior rectus because it's palsied, which means that the vertical action of the left inferior oblique will be unopposed, and it will create an increase in height as the balance of the depressor is lost. Okay, let's go through an example to make more sense of this, and let's come back to the patient with the right hyperdeviation primary that increases in left gaze. At this point, after step 2, we concluded that either the right superior oblique or the left superior rectus was the affected muscle. Now, let's assume that we have a positive Bielschowsky head tilt test on tilt right, which means that we see an increase in the vertical deviation when the patient tilted right. It means that one of the muscles that is recruited whilst tilting right is the affected muscle. This also means that the 4 extraocular muscles recruited during tilt left are unaffected. So the right inferior oblique, the right inferior rectus, the left superior rectus, and the left superior oblique are unaffected. Okay, let's move over to the tilt right. Okay, one eye is encycloducting, the right eye, and the other eye, the left eye, is excycloducting. Now, come back to the two muscles that we thought are potentially affected. It's either the right superior oblique and the left superior rectus. These are both encycloductors. Actually, each time you come to the end of step 2, the two muscles you'll have will have exactly the same torsional action. You'll always end up with two superiors or two inferiors. In this instance, we've got the superior oblique and the left superior rectus. So what we can see is when the patient is tilted to the right, that the left inferior oblique and the left inferior rectus can't be the affected muscles because, one, they weren't on our list as being potentially affected, but also they're excycloductors. And the muscles that we have left over as potentially being affected are encycloductors. So immediately we also remove the left inferior oblique and the left inferior rectus. So what we're focusing on here is now the eye that's encycloducting, which has recruited the superior muscles, which we know, and we know that the affected muscle is an encycloductor. And what we have here is the right superior rectus and the right superior oblique as encycloductors. And from the two potentials, the right superior oblique and left superior rectus, it has to be the right superior oblique because the right superior rectus was not suspected. Okay, so we've isolated the right superior oblique as being the affected muscle. Now, just to reiterate, why did we see an increase in height on this tilt? This is because the right superior rectus is now unopposed by the palsied right superior oblique and will elevate the eye, and we'll see an increase in height when the patient tilts to the right. Okay, let's go through an example or one more example so that we can work through Parks-Helveston's 3 steps and revise what we've just learned about how to isolate the vertical extraocular muscle that is affected. Okay, so step 1, identify the vertical deviation in primary position. We've got 8 vertical muscles. We're now going to indicate which 4 of these 8 could potentially be affected. Now, in this particular example, you can just tell that the left eye is hypertropic. Okay, so we have a hyper deviation of the left eye. So the two depressors of the left eye, the left superior oblique and the left inferior rectus, are suspected, as are the two elevators of the other eye, the right superior rectus and the right inferior oblique. Remember, at the end of step 1, you will always have 2 depressors and 2 elevators that are potentially affected. So moving on to step 2, in this instance, we're now going to look at the vertical deviation in right gaze and in left gaze. So step 1, we've got 4 extraocular muscles that we're considering: the right superior rectus, right inferior oblique, left superior oblique, and left inferior rectus. And then we look in right gaze and left gaze, and we can see here clearly that there's an increase in height in right gaze. This means that the vertical muscles that we suspected, which work in left gaze, can be eliminated. So these now are off the table, so to speak, and are considered to be unaffected muscles, which leaves us with the right superior rectus and left superior oblique as potentially the affected muscles. Okay, so step 3 is the Bielschowsky head tilt test. And again, just to reiterate, we're expecting that on tilt right, we're going to get encycloduction of the right eye, excycloduction of the left eye, and when we tilt left, we're going to get encycloduction of the left eye and excycloduction of the right eye. Okay, now immediately upon observation, we can see that the increase in height is happening on left tilt, and there is no increase in vertical deviation on right tilt. So this is the position that we're most interested in. Okay, so the position we're really interested in is tilt left. Now we know that it's either the right superior rectus or the left superior oblique that is the palsied muscle. These are both encycloductors. Now on tilt left, the eye that is encycloducting is the left eye. This means that the pausing muscle must be of the left eye. So immediately you can see that it's going to be the left superior oblique. But if we just take us through the example, it's either the left superior rectus or the left superior oblique. And given step 2 of the process of Parks-Helveston's 3 steps, we know it has to be the left superior oblique. And if we want to explain why it is that we've seen this increase in height on tilt left, well, it's because the left superior rectus is unopposed by the left superior oblique as that eye encycloducts during the head tilt. Okay, so in conclusion, in this particular example, we have a left superior oblique palsy. And one more final point that's of clinical significance is that you should note that a vertical rectus muscle has more of a vertical action than it does torsional. However, an oblique muscle has more of a torsional action than a vertical muscle. Now, if you think about the extraocular muscles and their position on the globe, you can see from the position of the globe that the obliques, the way in which they enter or insert into the globe, they're going to create much more of a torsional movement than the vertical rectus muscles, which don't have or don't come in as much at much of an angle or as much of an angle. Okay, why is this important, or how is this clinically significant? The reason it's important is that when you have a superior oblique that is the affected muscle, so let's say in this example here we've got a right superior oblique palsy, the muscle that remains unopposed is the right superior rectus. Now the right superior rectus is an elevator, and because it's a rectus muscle, it has a strong elevation action. So you're going to see on the Bielschowsky head tilt test an increase in the vertical deviation. However, say we had a right superior rectus palsy. So say the right superior rectus was palsied and it was the right superior oblique that was unaffected. Well, what would happen is that the right superior oblique would be unopposed, and what you should see is an increase in the deviation because the depressor is unopposed. However, sometimes clinically you may not see much of a change in the vertical deviation because the superior oblique is more of a, or has more of a torsional effect than a vertical effect. So the Bielschowsky head tilt test may not produce a positive outcome in some instances, not in all, but in some instances where the palsy is the rectus muscle, because the unopposed muscle has more of a, which is an oblique, has more of a torsional than a vertical movement. So just be aware of that, that if you have a negative Bielschowsky head tilt and you think it is a rectus muscle that's palsied, that could explain why you're not getting a positive head tilt test. And finally, let's come back to Miss Jones. Now, we have 2 sets of information that will assist us in looking at Parks 3 steps. We have the deviation in primary position, 8 prism diopters, a deviation in right gaze, the deviation in left gaze, and then the Bielschowsky head tilt test performed. In some instances, you'll actually see the Bielschowsky head tilt test recorded as part of the PCT, which is also fine. In this instance, we've seen them separate. Okay, let's start off with that deviation in primary position. We've got an 8 diopter base down fixing left patient, so we've got a right hyper deviation, and this is also identified in the cover test. So we have the 2 depressors of the right eye, the inferior rectus and superior oblique of the right eye as potentially being affected, or we've got the left inferior oblique or the left superior rectus, the 2 elevators of the left eye that could be potentially affected. Okay, we now have the patient moving over into left gaze where there's an increase. So we now can identify the left superior rectus or the right superior oblique as the 2 potentially affected muscles. We have 2 encycloductors again remaining after the second step. Okay, the third step tells us that on right tilt there is an increase in the deviation. The encycloducting eye in this instance is the right eye, and that leaves us with the right superior rectus or the right superior oblique being recruited on tilt right, for encycloadduction. And of those two, the one that we have potentially left is the right superior oblique. So we have a right superior oblique palsy that is being identified here through the Parks 3 steps. Now we'll have a look at this case overall with its other findings, but this particular Parks 3 steps is pointing towards a right superior oblique palsy. So in summary, we utilise a Parks-Helveston 3-step test to identify the affected muscle where we have a vertical deviation and we suspect that it's neurogenic in nature. Step 1, we have the 8 vertical extraocular muscles, and we will identify the 4 of those which could be causing the vertical deviation that we're noticing in primary position. Step 2, we will take a look at lateral gaze or right and left gaze and see where we have an increase in the vertical deviation. By doing this, we'll find of the 4, the 2 muscles which could potentially be causing the increase in height in lateral gaze. And finally, we have step 3, in which instance, when we tilt the head, what we're doing is we're isolating the encycloadductors of one eye and the excycloductors of the other eye, which assists us to make that final diagnosis or to isolate the affected vertical muscle, which is causing an increase in height on tilt. Okay, that brings us to the conclusion of this video. Thank you for watching.